1, 2, 3. Yeah, everything's working.
Yeah,
So welcome to our presentation on programming LEGO Mindstorms with .NET. So just before we begin, we'll briefly introduce ourselves. My name is Anders. I'm a software developer at a company called FOSS in Denmark. I like to play with Legos and ride my mountain bike and play golf.
Yeah, and my name is Lars, and I also work together with Anders, and I love electronics and also playing with Lego. And I'm also a father of 3, and in my free time I play underwater rugby and mountain biking. So, okay, so we just have an agenda for today. First we will tell a little bit about what LEGO Mindstorms is. Then we will tell a little bit about our motivation for creating this custom firmware. And we will show some different applications. And then finally, we hopefully will have some time for questions.
Yeah, so before we dig into the MonoBrick library, we'll just go through asking this question: what is LEGO Mindstorms? Basically, LEGO Mindstorms is a platform for creating and programming robots. It all started more than 25 years ago at MIT, where Seymour Papert was working on how to empathize programming with children, and he was the creator of this Logo programming language. So 10 years later, Lego and was ready for their first lineup, and it was a huge success. That same year, it was already sold out before Christmas, and what was really surprising was that all the buyers of this set was actually adults. So and it was due to the fact that the RCX, which is what the first version is called, was quickly reverse engineered. So it all started on this website, which had a complete documentation of what was inside this unit. So from there, a whole range of nice tools came out, C-like languages that could execute on the existing firmware. Later, you could write native C++ programs, and there was even a Java virtual machine running on this brick. So Lego was actually faced with a question on how to deal with the fact that their product had been reverse engineered. So at first they were a little bit concerned about this, but eventually they made a very wise decision on actually embracing this, because it is actually part of the Lego philosophy, like try and tear things apart and see what comes out of it. So they actually, yeah, like I said, embraced this way of thinking. So for the second generation, which came out in 2006, they actually open sourced everything. So you can download and view all the schematics. You can download the firmware and stuff like that. So they really tell people to go out and hack our product and see what comes out of it. So for the third generation, which was released a couple of years ago, this one is called EV3. It is more or less the same as the second generation, apart from some minor differences. But they are actually very important, because what you can do now is you can have Wi-Fi support using the USB, and there's also an SD card slot. And most importantly, it runs on Linux. So that means that you can actually take the firmware that Lego developed, and you can modify this Linux image, and you can make a firmware replacement. So what is actually inside, or what comes with this LEGO Mindstorms? There's a number of sensors. I'm not going to go through all of them, but just briefly show some of them here. There's a touch sensor that where you can detect whether or not a button has been pushed. There's an ultrasonic sensor that makes it possible to read the distance. And there's also a light sensor that makes it possible to detect ambient light reflected light and also detect different types of colors. There's a gyro sensor that makes it possible to detect angular velocity and angular acceleration. It also comes with some servo motors that makes it possible to move your Lego creations very precisely, so you can make all sorts of awesome robots. Yeah, and then there's also a huge variety of other sensors created by third-party companies. And there are also support for the old Lego sensors from the first and second generation of the Mindstorms sets. So what you can see here is actually the latest, the one with the camera, is actually the latest sensor from a company called Mindstorms, and it is the Pixie Cam that you can attach directly to your Lego brick, so you can detect objects and color and movement in 3D space. So it's really a powerful sensor. It's also possible to create your own sensors, and then you can connect that to the Lego Mindstorms bricks. Here we have a sensor that we created. It is just an RFID antenna connected to a microprocessor that then talks to the Lego brick using I2C protocol. But it also supports UART protocol. So there are a lot of different sensors inputs that you can get to work with your robots. So basically, one of the things that is still missing is a great programming language, because the Mindstorms sets comes with a visual programming language for kids, and that's also fine. But I mean, if you want to do something really powerful, then that's not the way to go. So,
okay.
Yeah.
Yeah. So, what was the motivation for us to start this project? So, we really want to explore the possibilities that we would give the programmer of the robots if we have the .NET framework and all the libraries that is available. And we were quite sure that this will empower the robots. And of course, it will allow a lot of programmers to use their favorite programming language to program the Lego robots. So we were we were curious what kind of requirements that was needed for running the .NET framework. The first thing was that it wasn't a Windows system, so we need but we still need the .NET framework. But luckily, there's an open source project called Mono, which is an open source implementation of the .NET framework. We could see that Java was already running on the EV3, so why should it not be possible to actually use .NET? There could, of course, be some limitation in the kernel or library requirements that will be difficult to overcome. We were also interested to see what it would take to port the .NET framework to this embedded system. Maybe it was already available, and then it will be quite easy. But if it wasn't available, what will it take to actually to port it and get it up and running? And of course, we wanted to make our work open source so that other people could use it, and we could see what other people could do with these tools. Okay, so how do you get the .NET framework up and running on an embedded Linux? Inside the EV3, we have an ARM9 core running at 300 megahertz. We have a decent amount of memory, and has USB host and device capabilities, has a small display, monochrome display. And most important, it has a feature that makes it able to either boot from the internal flash, where we have the standard firmware from Lego, but you can also put in an SD card, and then it will just boot from there. So that it's very easy to make a custom firmware. You don't need to modify the brick or anything. You can just take your custom firmware, put it on an SD card, and then boot it up. And as Anders told, everything from Legos is open source, so you can just download the Linux kernel and everything. Okay, so we need to get the .NET framework. .NET runtime. So how do you do that? So we just do an apt-get install, and that is not really possible. The EV3 runs a special Linux distribution called Ångström, which is a special Linux distribution tailored for embedded systems, and it has a very limited amount of packages available. So then we thought maybe we could just download the binaries somewhere, but that is not really easy to find the correct binaries, because it has to be made for this specific processor core, and the Linux environment, and everything has to match up. But then, of course, the source code for the Mono framework is available, so we just download that and compile it, and that, yeah, that sounds easy, but the first thing is that you can't just compile it on the EV3, because it doesn't include a C++ compiler, and if it had a C++ compiler, it will still be take too long time. So that's not really a suitable way to do it. So in order to do this, we need to use a cross compiler, and and it's fairly easy to get a cross compiler so that you can compile on your Intel PC and then generate code for an ARM core. But it's not that simple to get it to work with the .NET runtime, because this is a very complex build setup. And during the compilation, it will actually compile some programs, and it will later run these programs. And if you just use a normal cross compiler, you will run into trouble, because when you compile a program, you can't just run the program, because it's for a different target. But then, luckily, there's a tool that's called Scratchbox, which is a cross-compilation environment, which is actually able to compile for another target, and then afterwards execute the programs. And it's emulating the target environment, and with this, it's actually possible to compile the Mono framework and everything. And yeah, and this is how we managed to compile the framework on a desktop PC, and then we could move it onto the EV3. So the first thing we want to investigate was if this, how is the performance on this? Is this anything that you can? Is it usable for anything? And the first thing we found out that it was actually running quite well. By default, it uses just-in-time compilation, and on this limited hardware, just-in-time compilation is not running very fast. And so you will see that when you start up your programs, you will have a delay, and later on, the first time you call some functions and so on, it will take some time for the just-in-time compilation to run, and that's not always desirable in your applications. But when it was after the just-in-time compilation has run, everything ran quite smooth, and it worked really well. The .NET runtime and the Mono framework has a feature called AOT compilation, so which means ahead of time compilation, and this can actually mitigate this problem with that just-in-time compilation gives. When we started using it, we found out there was different kind of problems. It was not always working as we expected, and in order for it to work correctly, we have to AOT compile the complete framework so that everything in the program was AOT compiled. And this, of course, this takes a lot of time and so on, but we just have to do that once, then we can include all the AOT compiled libraries and so on the firmware we have. And we also discovered that the AOT compilation can give some problems when you do certain stuff, like XML serialization and deserialization, because internally in the .NET, this is actually based on dynamically creating different kind of code. So that's one thing that gives problems. There's also problems with features like dynamics, which is not really compatible with AOT compilation. So with this, we were able to create a firmware image, so that you can just download from our website and put it onto an SD card, and then you can plug it into your EV3, and you have everything you need to actually run .NET programs.
Yeah. So once we had this image, which included the Mono.NET framework, we needed to create some hardware interfaces. So we started out by creating some wrappers for hardware configuration files, like configuring Wi-Fi connections, shutting down the operating system, and stuff like that. We then did an implementation of a C# wrapper for the Leetspeak library, the C library that comes with the Linux distribution. And we used that for creating memory maps of files that where we could read sensor values and motor data. We also used this for creating device input-output controls files for configuring sensors and LCDs and other hardware stuff. So once we had that, we just needed to create some base classes for motors, sensors, LCD, and other hardware. And then we expanded these base classes to support all the official LEGO sensors that comes with the set, and also support for the first and second version of the Mindstorms series. We also created support for a number of third-party sensors, especially from MindSensors and Heintechnik, which are the two companies primarily that creates third-party sensors. And then we created some easy-to-use base classes for I2C and UART communication. That means that if you have a sensor that isn't supported by the library out of the box, then you can quite easily add support for that sensor. All this is put together in a single DLL file, which is created when we build our system. So you just create a normal C# or .NET application and include this DLL, and then you have access to all the hardware. Yeah, we have some documentation. I'll just briefly show you here. Or maybe it's just a bit small. So yeah, we have Jesus. We have some documentations here. You can see we have a number of sensors here that have support, and we even have support for the display here, and we even have a small dialog and menu system that you can use. So, and I'm just going to show that in a short while. But we also created what we call the firmware application, and the firmware application is a C# program that starts when you boot from our image. So with this program, you can use the buttons on the front of the EV3 and use that to select some of the programs that has been uploaded to the brick and start them. You can connect to a Wi-Fi network. You can check for updates. And this includes checking if we have uploaded a new image to our website, and also checking if there's a new firmware application. And if that is the case, then you can actually download that application to the brick, and then the next time you boot, it will just start with the new application. We are also able to detect whether or not there's a new hardware DLL available on our site. So yeah. You can also get some brick information like IP address and mono version and kernel version and stuff like that. And obviously, sometimes, I don't know why, but sometimes you need to shut down the brick. Now I'll just try and give you a quick demonstration. Oh, sorry, I just need to tell that when we did this firmware application, we quickly realized that it was actually quite cumbersome to add some features or fix some bugs and then upload it to the brick and then see if everything was correctly, and then it was just, took some time each time. So we started looking into creating a simulator where we could debug our firmware application on a Mac or a PC. So, and this actually worked out pretty well. We were able to test our update system and our settings system and also the menu system just from directly on a PC on a Mac without uploading the program to the brick. And once we had that working, we started investigating on if it were possible to actually run programs that were intended to run on the brick on the simulator. So, and that actually turns out that can also be done. But we haven't added support for all hardware because, yeah, it just takes some while and it's not such an easy problem to solve. So you cannot have support for motors or sensors. So that means if you create a program that you need to run on the brick that access these hardware components, motor and sensors, the program will actually, if you run it on the simulator, it will throw an exception and crash. So running programs that are intended to run on the brick in the simulator is somewhat limited, but can still be done. So I'll just try and demonstrate this firmware application. So, yeah. Yeah, so this is what the simulator looks like, and this is also the program that you will see when you boot the real brick. So we have some options here. We have programs. I can just press enter and then I can see the list of programs. We have Wi-Fi. I can enter the ID of the Wi-Fi network, and I can enter my password, select whether or not to use encryption, and now I'll just disconnect. Actually, this one, since it's running on the simulator, it doesn't do anything. But this is what this is just to test that everything is working on the simulator. So yep, and now it asks me, do I want to connect at startup? Yes, I would like that. We have some settings and also this feature for checking for updates. Oh, actually it says that there's a new image available. I can download it from our website or from this FTP site. Yeah, so yeah, we have some brick information here where you can see the IP address, and I can shut down. So I'll just try and run a program now. So what you'll see here is I'll have a few options here. I can AOT compile my program. I can run it in AOT mode, which was what Lars talked about, ahead of time compilation, and I can delete the program. I'll just try and AOT compile it. So it says program already compiled, recompile, yes. I'll just try and do that. And again, on the simulator, it doesn't really compile the program. It just does, yeah, actually nothing. but just to give you an idea of what you can do on the real thing. So yeah, now I've compiled the program. I'll just try and run it. And now the program is actually running, and you can see we actually using the our menu system here. And for those of you who haven't noticed, it is actually an email client. So why use a phone when you can use your LEGO Mindstorms brick to send an email? So we have some settings here, like SMTP server, port number, stuff like that. and I can add some receivers. I can add a subject. So I'll just enter my message. Hi. It takes a really long time if you want to. So I wouldn't recommend this for work, but yeah. So let's see. Now I have a message. I can send the email. Yeah, it was successfully sent. I'll just try and zoom out, and hopefully I'll get a notification. Let's see. Got lost in cyberspace. The demo effect. Oh. Anyway, hopefully it'll arrive soon. Yeah, so that's pretty much what you can do with the simulator, and that's how our firmware application works. Yeah.
Okay, so how do you actually make a program and debug it on the EV3? So the Mono framework actually got built-in support for remote debugging, and this is very useful when you have an embedded system. And this debugging is integrated in the Xamarin Studio, which is free to use for this kind of projects. And a friendly guy from the community has actually made a plugin for Xamarin, so it's very easy to make programs and projects in Xamarin. And I will just make a quick demonstration of how to make a program. So here we are.
Still hasn't arrived.
Okay, so here I have my Xamarin Studio, and it is I have configured the plugin to connect to this EV3 here, and that is connected on the Wi-Fi. I could also connect to it directly with a USB cable. So I will just make a new project from scratch here. So when I have the plugin, I have some special project types. I have a MonoBrick project here for C# programs. I could also do an F# program if I want to do that, but I think I will stick with the C# for now. And I will just give it a name here, and I'll just okay. It started up and giving me a simple template of program, and this is just a program that runs with the motor, so I'll just remove that. And so what I want to do now is that I have this color sensor connected here on port 1, and I just want to read out the value from this color sensor. So in order to do that, I just need the namespace with the sensors, and then I can make an instance of my color sensor, and I just have to tell it that it is connected on sensor port number 1, and then I can try to read out the value. If I can type correctly, read color, like that, and I can just put a breakpoint here, and then when I select start debugging here, it will download. First it will compile the program, then it will download it to the EV3, and it will start it up, and hopefully I will. And now you can see I stopped at my breakpoint. I can just step over this one, and I can step over the next one. And now I can try to inspect this value. And it says here that the value is blue, and also, as it's also the color that is on here. So it's very simple to get a program up and running. Yeah, I think that would be that. So. Okay, I want to show another application that a guy from the community has made. What he wanted was to build a vehicle that he could remote control, and he wanted to be able to remote control it from his smartphone or a PC or whatever. And the way he did it was he just made a simple web server by using the HTTP listener that is built into the .NET framework. And then he could just make a couple of REST services to control the robot. And yeah, I have this program running in this one. And then I can just have here. So now I'll just navigate to the page. And he made a simple HTML page with some JavaScript. And now I can just click here, and the robot will run. And of course, I can also take another device. So if I have an iPad or something, I'll also just go to this web page, and it will work. So it's actually quite simple to make an application like this. And so yeah. Thank you.
Yeah. So on to the next application that we want to demonstrate. So in robotics, it's actually so much fun to do real-time control systems. So most of the problems that you want to solve can actually be done using a PID controller. So maybe some of you don't know what a PID controller is, so I'll give you the shortest ever crash course on a PID controller. It's simply a way of hitting a target that you desire. So the principle is that you calculate an error, which is the target that you want to hit, minus some measurements that you have done. Then you calculate an output based on the PID values that you have placed in your controller, and then you apply that output. So that was ABC on PID controllers. So no reason to read big books or anything, just, yeah. But luckily MonoBrick has a built-in PID controller that you can use. And for this example, I'll try and use the ultrasonic sensor for keeping a fixed distance to a wall. So I'll just try and show you some code. We'll just close this. Yeah, whatever. So here we are. This is actually the main program. So what we do is we create a PID controller, which has some control values, and the 800 here is the target value. So our PID controller just inherits from the PID abstraction. So all we actually need to do is implement 3 abstract methods. One for calculating the error, one for applying the output of the controller, and one for stopping the controller if we want to. So in our case, we don't want the controller to stop, we just return false. So that means the controller, once it's running, it just runs forever. You could do something like, if I'm inside the target plus minus something for some period of time, then I would have the controller to stop. In our case, we'll just return false. So we calculate the error, we read the distance from the distance sensor, we subtract that from our target value, and then we return the error. And when we get the output from the controller, then we just apply that to both motors. Really easy. Not much code to get a PID controller up and running. So I'll try and demo this. I have a robot here. I have the program that I just showed you downloaded into the brick, and I have a wall. So I'll just try and I'm just waiting for. Did it start? Yeah. Now you can see there's actually light in the ultrasonic sensor. So I can move the wall, and the robot keeps a fixed distance. So only a few lines of code to get this working. Yeah. Every time I lean forward. Yeah. Yeah.
Okay. Hello. Yeah. Another application that has been made is this Rubik's Cube solver, and it's implemented in C#, and is solving the cube by first analyzing the faceless. So it's scanning the color of all the faceless, and then it tries to find the optimal solution to the Rubik's Cube. And this is done by using this CoSimba two-phase algorithm, which is actually the algorithm that was used by the scientists just a few years ago to prove that every Rubik's Cube can be solved with 20 or less moves. And yeah, so now we'll just do the scanning, and this will take some time. But yeah,
we'll just wait for the scanning to be done, and then we'll move on to the next. And when we have some time for questions in a while, then we can see it finish its work.
So what is also interesting in this one is that this robot is built just with the standard Mindstorms set. So you don't need any extra things or anything. You can just build this with the standard set. So now it's actually, it has already calculated the solution and is starting to solving it. Okay. So I can see that, yeah, it's actually. I don't think.
Done, so
yeah,
we'll
I don't think it will take a long time here. So maybe I wasn't that true. Yeah. So.
So yeah, we're moving to the next application. So this application actually demonstrates how you can use third-party DLLs. So what we have created is a REST service using Nancy. So we just used this NuGet package or packages, because you need quite two, I think, for Nancy getting up and running. But once we had that running, we could actually create a REST service where you could move motors, you could read sensors, you could show the LCD, and you could also display some web pages that give you documentation of the REST service and an overview of the state of the brick. So I'll just try and navigate to. And as you can see here, we have the brick running here, and we have a single motor connected to port 1. So I'll just try and go. There's a long list here of things that. Do I need to zoom? Or yeah. Okay. So. Yeah. Yeah. Okay. So I can just try and get some status back from the motor. It says motor A, speed, and position as a JSON. it's a JSON reply. So let's try and move the motor. So I can just enter 80, and it moves even faster. Let's just try and zoom in here. Okay, and I can say off, and it turns off the motor as well. Oh. And let's see with the LCD. Should be somewhere here. Actually, I can just get an image from the LCD. Let's try and go back here. Let's try and damn it. Let's just try and have this one as well. I just clear the LCD. We'll try and refresh this one. And now you can see the LCD is actually cleared. I can even I can go back again, and I can yeah. I can write some text down here. So now it just writes. I can just let's have some. Oh, let's see the text. Actually, let's see the text. Yeah. So. Yeah. And let's just try and go into this. We have this overview page that we can see. Hopefully this. Yeah. So actually this just uses the REST API to generate this page. So I'm actually able to take any sensor. Let's try with the color sensor. I'll connect it to sensor port 3. Sorry, 2. And you can see that it is updated in real time. And I'll just try and, I think I need to change the mode. You can see I can even pick through the different modes that the sensor has. This is the raw red, green, and blue values that you get, and this is, if I go back to color, then I can hopefully detect, oh, it says red, it shouldn't say red. Now it says white, which is the color of the, it says red, which is also the color. So you can get a real-time update on the screen. And just to finish off, I'll try and use these sensors from third-party companies. I'll just connect that to port number 4. Yeah, and you can see that's the Mindstorms medium range distance sensor, and it has millimeter precise measurement for distance. So, yeah, the last thing I want to show is actually you can also I'll just reset the tackle from motor A, and I can make it move. Oh, that didn't work. Yeah, it moves 600 steps. Yeah, so that's it for this demonstration. Yeah. So I think we actually are at the point where we are ready to answer some questions. So any questions? None. So yeah, there's a few down here. We have a mic. Or you could scream really high, but
Is it working? Okay. Is there a limitation how many of your programs can run? So could you have this Nancy server in the background to inspect what's actually going on in the, let's say, a robot moving around? Or is it one application running at one time?
Yeah, okay. So, yeah, you're actually able to run multiple applications. The standard, the firmware application we made will only support one program. But you can always just make an telnet connection to the brick and start more programs if you like that. So this is definitely a possibility.
So it's just a question of using a terminal and using HH to connect to the brick. So we actually don't need to start programs from our application running on top of it all. You can just start programs from a terminal. So if you like.
Yeah, and you can also quite easy change the startup script if you want to just start up your program when you turn it on. So that's quite easy also.
Yeah.
Yeah.
On what .NET instructions and .NET things you can use with ahead of time completion in Mono?
Yeah, I mean, would you like to answer that?
Yeah, there's as I talked about there's not any construction and so on. There will be a limitation. It's only dynamics, and of course, if you're doing some stuff with the XML serialization. So what is actually happening inside the XML serialization is that it's actually compiling some programs and run them, and that is also, of course, not really possible when you have AOT. But else, there's no you can't use all the normal things in .NET, and at the moment, the runtime we have supports .NET 4.5, so everything in there will work.
Yep. I may need to say that for this demo I did on Nancy, I actually cheated a little bit because when you call some of the URLs and you get some code executed, because it's not been AOT compiled, the first time you run or you type in an URL, you will actually see a small delay because it just has to JIT compile all of the stuff. So I've not been able to AOT compile the Nancy DLLs because of what Lars told you. It uses a lot of dynamics. So yeah. But the other robot that we had, where the one where we drove around, that just used some standard web server component from the .NET framework. So that executes much faster than Nancy. So yeah. Other questions? Yeah. There's one now. Yeah.
Have you had any MonoBrick robot wars, or is that planned?
No, we haven't had that. So, and we have, I mean, that's up to the users of the MonoBrick firmware. So we just spend all our time. Actually, I really like to build robots and program them, but I haven't had any time to do that. One thing being that I have 3 kids, but also because I need to support this firmware. So once I get the firmware completely done, I'll sit down and program a lot of robots. Yeah. Question down here.
So do you have any commercial application, or this is like pure for fun?
Only for fun.
Yeah.
Only for fun. Although I should mention that Lego was kind enough to give us a few bricks for this event. So, I mean, peanuts for them. Yeah. Any more questions? So everyone knows everything about MonoBrick. That's great.
Okay, but just if you have any questions or anything, we have a website, MonoBrick.
Oh, yeah.
And
good thing.
Yeah, there's a lot of guides and so on. So it's you can read about how to get started and so on.
Yeah. Yep, that's it.